risk management and vulnerability management are part of a process. And if you have a implementation in Amazon Web Services, you hopefully have a mature process for doing that. We want to help you understand how to build security into that process. So we are today speaking specifically about security within AWS, but a lot of what you know about your security posture and software development lifecycle apply in here. We actually have a few unique challenges and a few unique opportunities. As with anything else we do in AWS, there are some opportunities to improve the way we work. So the basic flow is that we can look for a couple of things. Most often when people think about Nessus and think about what we do at Tenable Network Security, we think about vulnerability identification, but we do a lot more. And in this instance, one of the more powerful things we can do is audit your configurations. And when I say audit, that can be to meet external requirements that are imposed on you, or ideally you're building your AMIs to work within Amazon's recommended guidelines. So we do audits of configurations, we identify vulnerabilities, we look for weaknesses that expose you to the threats, help you work your way through remediation, and then complete that cycle. It never truly ends. We also, and we'll get to this later, we can also help you find if any of your systems have been compromised. Hopefully, if you've got them locked down, they're not, but we can help you discover that, which feeds back into this cycle of auditing the configurations, patching vulnerabilities, making sure you don't have weaknesses. But to make sure that everybody understands what we're built on and what we're talking about, let me hand this back and take a look at what Amazon means for security and what Amazon does, which is quite a bit. Scott?
Oh, hi, everybody. Sorry about that. I'm Scott Ward from Amazon Web Services. So why deploy on AWS? There's lots of reasons here. Some of the big key ones are what you see listed here on the slide: lower cost, flexible capacity, and business agility. When it comes to lower cost, there's really no upfront investment for using AWS. So what you provision and what you use is what you pay for at the end of the day. So you're able to save time and money by paying as you go, turn things off, and you turn things on, use them for a little bit, turn them off and no longer pay for them. If the infrastructure configuration isn't quite right for you, you turn it off, you terminate it, you return it back to AWS, and create a new infrastructure that meets your needs more, and that's what you'll be paying for going forward. Flexible capacity, you can provision it and you can scale up and down as you need on the fly. So as your resource needs change and you need more processing power to cover short bursts of additional traffic, or let's say a month-end close of your financial services, the ability to provision extra capacity, utilize that capacity to cover that additional demand period, and then turn it off and return it back to the pool when you're done. Allows you to flex up and down to meet the needs of your customers and in your business. And then business agility, you develop, test, and deploy your apps faster. You have the ability to experiment. You have the ability to provision a particular infrastructure configuration, try it out, see if it works. If it doesn't work, return it back. Then go and try something else and see if that works better for what you need to be able to do. All of this without having to go through the process of trying to order, justify, provision, wait, rack, stack, cable infrastructure in order to meet your needs for what you're trying to accomplish. So let's talk about security within AWS. This is one of the key reasons that we're here today. So when it comes to AWS, security is always very important, and AWS provides the same familiar approach to security that companies have seen for decades. And at the same time, it really does this with providing the flexibility and scalability that comes with cloud computing. So we're going to start out here with an overview of security at AWS and review the concepts and outline how AWS makes your workloads more secure and how you can build an environment to meet your security requirements on top of what AWS offers. So the overall AWS computing platform. AWS got its start in 2006, and it's grown rapidly since that time. Today, it's the underlying infrastructure for companies around the world, including startups, enterprises, and government agencies, and it has hundreds of thousands of customers in 190 countries around the world. A little background on AWS. After over a decade of building and running highly scalable web applications, the company Amazon.com realized that it really developed a core competency around operating massive scale technology infrastructure and data centers, and they embarked on a broader mission to really service a new customer segment they felt that they could service, which was developers and businesses. They offered up a platform of web services that could use to really build sophisticated, scalable applications. Out of that came AWS, which is a comprehensive cloud services platform offering compute power, storage, content delivery, and other functionality. It really enables these businesses to cost-effectively deploy applications and services with greater flexibility, scalability, and reliability. And it's all through the power of self-service, meaning that you don't have to go through and do long-term planning or wait for stuff to show up. You can actively react to demands at a moment's notice using some of those on-demand and pay-as-you-go models that we just discussed a few moments ago. So when it comes to security at AWS, we really rely on what's referred to as the shared responsibility model. AWS takes responsibility for security of the cloud, while the customer takes responsibility for security in the cloud. This model really reduces the overall total security surface area that the customer security experts need to focus on, and they rely on AWS for all the low-level infrastructure security. With that narrower focus, the customer security teams really get to focus on their attention on things like the operating system and the application level security. And their experts can focus and achieve better results in the areas that are more closely related to the differentiated value for their business or their mission, as opposed to some of the more generic, undifferentiated heavy lifting that applies to low-level security and compliance work, as well as infrastructure management itself. So on this slide we have here is the AWS portion of the shared responsibility model. That focuses on the physical security, facilities, compute infrastructure, storage, networks infrastructure, the virtualization layer, the endpoints, and the identity and access management capabilities. You add to that, we have the customer portion of the responsibility model, which is around network configuration, security groups, operating system firewalls, application security, service configuration, authorization, account management, and authorization policies. And with that, you end up with a more secure and compliant system than any one of these entities could achieve on their own, by each of them focusing on their portion of the overall responsibility model. When it comes to AWS, one of the top reasons that companies investigate and they really insist on cloud security, it's so that they can meet internal governance or external compliance requirements. So when it comes to that need, we get accredited experts to validate our cloud security. And as a result of that, we end up with compliance certifications that relate to many broad areas of the industry that are very important to many companies that are using AWS today. These things range from ISO certifications, SOC 1, SOC 2, SOC 3, HIPAA, ITAR, FedRAMP, Department of Defense certification around data security. All of these help companies better use their workloads and operate them in AWS in a confident way. And nothing is really better for the entire community than a really tough set of customers. So when a big institution gives us their stringent security requirements, we frequently end up building their requirements, incorporating their feedback into the overall platform. When this happens, everybody benefits from it. AWS doesn't build one-off solutions for anybody, so everyone gets the improvements that are made for an individual customer. And in many cases, this really can result in a better security profile than what each individual firm could possibly accomplish on their own. So previous models around security kind of focused on security of the data center itself. Here at Amazon, we're not only concerned with this data center security, but we're concerned of the security of the data as well. So along with the physical security of the data center, AWS has also implemented security around the network, the device or the infrastructure, and the actual data that's been created or used by the customer applications. As well, the physical security of the data centers. So Amazon, we've had years of building experience in designing, constructing, and operating these large-scale data centers, and that experience has been applied to the overall AWS platform. So when it comes to the physical security of data centers, they're housed in nondescript facilities. There's no big giant Amazon sign or giant balloon above their advertising. This is where our data centers are. We implement robust perimeter controls, intrusion detection, anything to kind of keep anybody from who doesn't need to be there out of the building. Once people are actually allowed in the building, there's strictly controlled physical access. People must pass two-factor authentication twice before they're even allowed to get onto the data center floor. Any visitors or third-party auditors have to sign in, and they're escorted at all times while they're in the building. All access is logged and reviewed on a regular basis, and only people who need to be allowed into the building are actually allowed into the building. Any AWS employees who have data center access, once they leave the company or their job no longer requires them to be in the data center, their access is immediately terminated and they're no longer allowed in the building. We also employ a segregation of duties policy, meaning that employees with physical access don't have logical access. So somebody who's responsible for racking and cabling and turning on some of the equipment won't also be allowed to log on and actually add the infrastructure to the overall fleet. So on top of that, many of the AWS services we offer have different security features that will help out with security in your usage of AWS. These are here to help you, for you to use, and you can use as much or little of these as you need. Additionally, you can choose to use some other partner products, which we'll be discussing a little bit later in this presentation. Start out with Amazon EC2 Security. So within EC2, there's multiple layers of security which are both provided by Amazon, managed by Amazon, as well as pieces which are managed by the customer. The host operating system. AWS admins can log onto the host operating systems, but each one has their own individual SSH keys. They must log in through a Bastion host before they can log into the host operating system. And all their access is logged and audited on a regular basis to confirm and know what work the person was doing on the host operating system. The guest operating system, which is the EC2 instance, which is launched by a customer, at that point that is fully customer controlled and owned. The customer owns their root and admin keys. They own the generation of any key pairs that are used on that instance. And AWS admins can no longer log into those instances. EC2 offers a stateful firewall that has by default a deny all mode for inbound traffic. And customers must control that configuration of what they will allow for inbound and outbound traffic into their EC2 instance. API calls to EC2 are needed to require a X509 certificate or the customer's secret key. And when it comes to storage for EC2, disks are wiped upon volume creation. You have the ability to implement your own encryption, or as we'll use AWS encryption, as we'll talk about in a minute. And once they reach their end of life, all the storage devices are securely decommissioned. AWS CloudTrail. AWS CloudTrail is a service that records all API calls against AWS services within your account and delivers a log file to you of that information. These log files are delivered as JSON data into an S3 bucket, and each of the API calls is its own little JSON object that you can dive into to figure out what information was requested, what IP address it came from, what information was returned back, to determine if this is an appropriate call or not. It allows you to cover 21 different services currently within AWS. And it's something you can use yourself to analyze activity against your AWS account, or even tie in with another partner product to further evaluate usage against your AWS services and detect any possible security violations or compliance risks that you may have. Amazon Virtual Private Cloud, or VPC. This is your own private isolated network within the overall AWS cloud. You could specify your own private IP address range for your VPC, and within that you can define one or more public or private subnets. You can use network access controls to actually control the inbound and outbound access to those subnets. You can use the security groups that we talked about earlier to actually control what inbound or outbound traffic is happening on your EC2 instances. And you can take your on-site IT infrastructure or corporate location and actually bridge that to your VPC via VPN to have one larger network available to you using your AWS resources as well as any of your corporate resources. So a quick overview of what VPC network security controls look like. The overall large box is your overall VPC. We've got traffic coming in being handled by routing tables as well as access control lists, which are controlling inbound and outbound traffic. In this case, we've got two different subnets. One of them could be public, one of them could be private. Each of those subnets are communicating to security groups for both inbound and outbound traffic, which are then allowing traffic or denying traffic into the final EC2 instances that are behind those security groups. Storage encryption. So S3 and Elastic Block Storage are one of the more common storage solutions on AWS. And there's some different data protection and encryption options that exist with each of those services. So first, we have AWS provided encryption on both S3 and EBS. On S3, it's called server-side encryption, and as soon as the object is placed onto S3, AWS will encrypt it. With elastic block storage, you can choose to have an encrypted volume, and in that case, the data is encrypted at rest as well as in transit to the EC2 instance that block storage device is tied to. With S3, you can also provide your own encryption keys for S3 to do the encryption. So you can, when you upload an object, you can give your encryption key, and S3 will take care of that heavy lifting of doing the actual encryption and encrypt the data for you, but it will still be with your own keys, and you will still own the keys. And finally, you can encrypt everything else yourself and manage the keys. So with EBS, you could create your own encrypted file system on the storage volume that you want to use. Or with S3, you can encrypt the data prior to sending it to S3 and then put it in S3 encrypted with your keys. Next, we have AWS Identity and Access Management. And this is really your service for controlling your resources and usage within AWS. So you control users and groups within the account. You issue security credentials either via access keys or logins and passwords. You can enforce multi-factor authentication. You can implement policies that really control access to the AWS APIs. And these policies can be very fine-grained. They can be at the service level and then even within actions within the service. So for example, you could say somebody's allowed to access the EC2 APIs, but they're only allowed to start instances and they're not allowed to stop instances. So you can get very fine-grained there. You can get deep integration with some of the AWS services. For example, S3, you can actually implement policies on objects and buckets within a particular your account for S3. And it's not there for operating system or applications. This is just for controlling your overall AWS account. If you're looking for things controlling operating systems or applications, you would be looking at LDAP or Active Directory or some other partner authentication solution for that information. We have AWS Trusted Advisor. So this goes and checks your configuration and usage of AWS. The results of your accounts are compared against best practices, and then you're alerted to any opportunities to close security loops that may exist in your particular AWS account. The key areas here, as far as security loops here, are any security groups in EC2 that maybe have some wide open hosts or ports, some S3 policies that might be a little bit too wide open if you're not using multi-factor authentication on your root account, if your password policy doesn't seem to be strict enough, or if you're not using CloudTrail auditing. These will all be there and kind of help you give some visibility into how you might be improving security within your overall AWS account. And then we have two new services that were announced at our recent AWS reInvent conference back in November that I wanted to highlight when we come talking about security. There's the AWS Key Management Service, which is a centralized key management solution that is built and managed in AWS. You get full auditing of this service, so as you have your keys there, you can track and see usage against those API calls through CloudTrail. And the keys are secure. They're never transmitted outside of AWS region in which they're created, and they're there for you to use and control against your overall AWS account. And then we have AWS Config, and this is a new service that allows you to kind of get a full visual overview of your AWS account, your resources in all the different regions, know what's running there, and also get visibility into what any updates about a configuration change that's happened on one of your AWS resources. Get an SNS notification around that, and also have a visibility into how deep does a particular change that you want to make go. So if you're looking to maybe make a change to a particular security group, you can use this service to actually say, well, how is that security group used? What EC2 instances is that security group tied to? So that when you make that change, you know what it's going to impact, or maybe you don't make that change because you know it's going to impact more than you potentially thought it would. Now it's time to transition in a little bit into the partner side of this and talk more about the middle part of our overall shared responsibility model, which was the customer section. So when we look at solutions offered within the partner ecosystem, there's really a close correlation to that customer portion of the shared responsibility model. These solutions are there to help with the customer portion. And when it really comes to ensuring that their environment's secure and where they may be at risk, what options does the customer really have? So I'm going to turn it back over to Jack here to talk more about one option that you can really use from the Tenable side, is secure and protect your AWS environment.
Thank you very much. So let's dive into what we do. As was introduced in the beginning, my name is Jack Daniel. I am a strategist here at Tenable Network Security, and we focus on helping folks secure their environments. In the case of Amazon Web Services, there are a lot of fundamental things that you would normally worry about, which, as Scott has just explained, are handled for you by professionals, and there are tools made available to help you further advance those lower layers of the stack that can cause us grief. Fortunately, we've got some tools to help you close the loop on that as well. We can bring in what we have with Nessus to add a lot of components. So why is vulnerability assessment important? It enables AWS customers to find vulnerabilities, misconfigurations, and systems that are also already compromised, should you have any of those. This also provides vulnerability scanning for the cloud from and other AMIs, third-party AMIs from within the cloud. So we have a direct connection, a better perspective on what's happening. And we can help secure the AMIs throughout your SDLC or whatever you use for security from creation and coding through deployment and retirement. So that's why it's important. What are we going to do about that? There are some unique concerns. Obviously, if it's not a server in a rack that you control, it adds a few unique concerns, but we can address all of these. So first, how do we make sure that what we've deployed is properly configured? How do we identify instances that are running vulnerable operating systems? How do we check for compromise in these systems? An issue is in a shared environment, even an isolated shared environment, because of the potential for disruption if not properly configured. You need to get authorization to scan unless you're using an approved platform or use approved program. So in this case, scanning does require authorization. Some tools require multiple different tools or multiple different scans to find vulnerabilities, compliance issues, web application vulnerabilities, etc. We can do that unified. And web applications, again, we can take care of all of that in this. And so those are challenges you have to think about. We obviously are here today because we do a great job working with Amazon in providing solutions. So a couple of the other challenges, if you need to manually install scanners, you may be doing a lot of instances and trying to make them as streamlined as possible, trying to make compact and lightweight and highly efficient systems. You don't want to add scanners to as many as, or a lot of your systems. You don't need to worry about tracking by using our solutions. You don't need to worry about tracking by IP. One of the challenges in normal scanning environments is that you tend to be limited to either using hostname or IP address. In a highly dynamic environment, such as AWS, we need to use instance ID to track that. So again, the scan request form. These forms are simple enough, but as I said, you don't want to do things that haven't been thoroughly checked and approved by Amazon and outside of the approved time window, so you need to do that. So that means you need to further plan beyond just trying to get up what works for scanning in your environment, but it needs to work within Amazon's. And then again, integrating the multiple components of scanning. So we recommend deploying or scanning throughout the process, throughout the life cycle. We recommend during development, scan your AMI images after each build to ensure that they're properly assembled, that you don't have insecure packages installed, that you don't have an insecure version of an operating system, that you don't have misconfigurations. And then if you do have a mature cycle, a DevOps type cycle, or run it through multiple steps, as you're deploying it, test it. As you're preparing to stage before going live, scan again. And finally, scan in production. Now, it's worth noting that in production, as the machine runs, patches are going to be deployed, patches are going to be issued. Patches don't just come out on Patch Tuesday. Vulnerabilities aren't only reported on the second Tuesday of the month on Windows. Linux vulnerabilities come out all the time. And occasionally Microsoft does out-of-band patches. So unfortunately, the challenges we face don't honor the calendar as much as we would like them to. So we encourage people to focus their scanning on doing it regularly or continuously whenever possible. Now, it's worth pausing here for a second to point out that we're going to talk a lot about patching, but one of the real advantages that Amazon Web Services running in this type of environment offers is that you may discover vulnerabilities or misconfigurations in your production environment, or hopefully not, but you may find compromised systems in your production environment. You may want to resolve that in the traditional manner, but the beauty of being in this type of environment is that you can build a new, properly secured system, know that it's a clean environment with no malware installed or no compromises, push that through development staging and production, and transfer the workload. That is one of the great beauties of this, is that rather than worrying about compatibility of patches or configuration changes, build it through your normal cycle, push that out, and never patch in production except in extreme or rare cases. That can be very empowering. So there are two versions of Nessus available for this. One is the Nessus AMI, a virtual machine that installs in AWS and can scan assets outside of the Amazon cloud. This is available as what we call BYOL, or bring your own license. It can be a license that you've already got, you've purchased from the Tenable store or from a reseller, etc. Apply that to the AMI. This type of scan gives you the flexibility of being connected back to your security center. Also with scheduling things with Amazon, you can scan inside. The more powerful platform for a AWS installation is the Nessus Nessus Enterprise for AWS. This is an AMI that is installed in AWS and scans AMI assets within Amazon's cloud. It's purchased directly from the Marketplace. Subscription is renewed automatically from the AWS Marketplace. So here's a bit of a diagram. In this case, if we look on the right side, you see the Amazon AWS console. Below that, you can see Nessus Enterprise Manager, which connects to remote scanners, which are part of that subscription for Enterprise Nessus. And from there, it will scan your AMIs as configured. And we'll take a quick look at configuration shortly. This is not a deep dive, but we'll give you an idea of what that looks like. For more targeted scans, or for smaller environments, or for large security center customers, what we see on the left, security center, in this case it's security center continuous view for your on-premise scanning. We've got the passive vulnerability scanner, Nessus locally, the log correlation engine, and security center managing it. You can connect those individual Nessus AMIs with your own licenses to integrate all of that data back into a single environment. So we'll take a quick look here at what this looks like. We've got blog posts and videos and other things that show this a lot in a lot more detail, but just so you know, if you're familiar with Nessus, this will be a very familiar process with just a couple of changes. In this case, if we take a look at a new scan policy, we can select a new policy. There's a section for auditing cloud infrastructure if you want to compare your system to Amazon's or your own preferences. You can see that cloud infrastructure, as well as all of the other tools that we'd expect in Nessus. Here we see the scan policy. It's worth noting the difference in this screen is that normally in Nessus or in any vulnerability scanner, you would input the DNS names or IP addresses of the target systems. Since we're talking about a dynamic workload and a dynamic environment, you supply your AWS access key ID secret key, and then set the regions that you want to scan. So these are the regions that you have your systems deployed in. And then you can see in the little inset there, you can select the Tenable AWS sample audit, which is based on Amazon's guidance. Or you can upload a custom file there that's a text editable file that you can use if you want to tune some of those settings, if you want to change password settings or SSL settings, a variety of things in that policy, you can edit those and upload your own. So move forward. The scan results look almost exactly the same as they would for any Nessus scan, any vulnerability scan, except you'll notice on the far left, under host, it's showing instance ID rather than a host name or IP address. And it shows vulnerabilities and information by severity, shows a list of different vulnerabilities. We'll take a closer look on the next slide. But also, if this were a compliance scan rather than a vulnerability scan, instead of seeing high, medium, low, or critical vulnerabilities, we would see pass, fail, or warn on those and give you an idea what needs to be done. So now we have this information, we know it needs to be fixed, but where do we go next? Well, the place to go next is to take a look at the remediation advice we've provided. So if we drill into those, we do provide suggested remediation. And in this case, you can see in this sample scan, there's some updates to Ruby and libxml and other things that need to be done. So we'll actually give you the details of what needs to be done as you work through. This is great for prioritization. If these systems under heavy load, it is, if you're doing e-commerce, probably have very short, if any, windows for maintenance right now through the end of the year. But this helps you prioritize it. It shows you the number of vulnerabilities and the number of hosts, so we can do a quick thing. If you only have time to do a couple of quick fixes, this makes sure that you get the most out of the effort that you expend in the process. So the key benefits to this type of deployment are it's low overhead. You don't have to do the manual approval process by using Nessus Enterprise for AWS. You can scan on demand as frequently as you want, as often as you want. It's integrated, so we will help you find vulnerabilities in your environment, vulnerabilities in production and in staging and in dev. We'll also help you find basic web application vulnerabilities, compliance and configuration errors, and we will cover the compromised systems by looking for signatures or known behaviors and checking reputation against databases of executable applications or running process applications. Deployments are quickly rolled out using AWS. The same thing that makes it easy for you to deploy multiple AMIs in a matter of minutes makes it easy for us to and Amazon to manage these scanner instances. In the case of Amazon AWS Nessus Enterprise, the administration is done through a single Nessus console, which can manage multiple scanners in a delegated environment or a single scanner, but it's the same, similar to what you're used to on the desktop. It's pretty much the same with a couple of additional options for managing multiple scanners and delegating authority to users. And it is, again, all done centrally from that cloud environment. Integration is the key. So we're going to do these scans and we're going to look for all of those things that you expect vulnerability assessment to do, but also cover compliance, configuration management, malware detection, etc. So recommendations. As we said in the beginning, risk management is a process. It's like a lot of things, it never ends. It is a process, not a product. It's not something you buy. We can help you with that process. We can do it by starting with the basics, reduce your attack surface. Here's where that remediation advice really helps, because you can get the most out of those remediation advices. You can also filter. Instead of doing everything, you can filter down your configuration to what's most critical to you. You can focus on vulnerabilities that are rated high or critical. You can filter down anything that you would do with Nessus normally. So you can filter on the most threatening components or most threatening misconfigurations by filtering what you run on that scan. So we're worked with Amazon to do this. It's tuned to work well. We stress patching, as I said, but VMs, you can validate, you can test your patches, but you can also, as I mentioned earlier, you can also, instead of patching in production, if your environment supports it, you can build new systems, test them, make sure everything works, roll them out without ever patching in production. It takes a lot of the challenges of patching in production away, makes it a lot easier to shift those loads. It also means it's a lot easier to fail back if you need to. And we recommend performing regular scans and continuous monitoring. Because you can scan as often as you want and as needed, you can do frequent targeted scans. You can focus, as I mentioned, on the most critical things on a daily or almost continuous basis, and then on a less frequent basis, do the deeper scans. It lets you stay on top of your environment with a minimum impact on your environment and on the networks. So we can purchase on the Amazon AWS Marketplace. Visit the Marketplace, search for Tenable, and you can purchase Nessus Enterprise for AWS with pre-authorized scanning for AWS, or the BYOL for scanning assets external to AWS and integration with Security Center or other Nessus Enterprise environments. With that, we've got some questions, and we'll start picking them up. So let's dive into the questions here.